Welcome back one more time, yet again, to Dave Does Math at Home. This is now part 3 of our video series on rational functions. Part 2 we graphed one. Part 1 we talked about what they are and why. These examples are going to go much faster now that we've finished with part 2 and I don't have to explain what a vertical asymptote is or where they come from anymore. So they should go pretty quick. I have here a extremely nice looking example for us to play with, and I'm going to get started right away by factoring it. You're going to have to factor the tops and the bottoms of these pretty much all the time, every time. The first one we started with was the linear and the linear. It's nice. It's not what most of these are going to look like. You're going to see a lot of quadratics here, and if you're going to set the top equal to 0 to get your x-intercepts, and you're going to set the bottom equal to 0 to get your y-intercepts, it helps out, it makes this go much faster if you just factor everything right at the beginning. There are other reasons that this is a good idea, and I'll talk about them more in a bit. But for now, I'm just going to factor. The top factors into x plus 3 and x minus 2, and the bottom is x plus 2. And that's it. It's all factored. So now I just need my 4 pieces of information. I need to know an x-intercept, which means we set y equal to 0. This is the one where we got to do kind of a shortcut when you did the last one. When you set a fraction equal to 0, that is essentially the same thing as setting the numerator equal to 0. So I'm going to sort of cross this out. Setting y equal to 0 is still officially the correct maneuver here, but as a practical shortcut, we can just say that we're setting the top equal to 0. It's going to save us a bit of time. And so if we set the top equal to 0, we have x plus 3 and x minus 2 equals 0, and we get that x is negative 3 and positive 2. These are intercepts. They are not asymptotes, so I'm going to write them as points. Negative 3, 0, and 2, 0. These are my x-intercepts. Next up, I want a y-intercept. Y-intercept means we set x equal to 0. So this basically just means we're looking at the back end. These pieces will all become 0. We're just going to look at the back of this. And we'll see that you get negative 6 over 2, which is the same as negative 3. So my y-intercept here is going to be negative 3. Next up, we need domain restrictions. Domain restrictions come from setting the bottom equal to 0. It should be pretty clear, I think, that the only domain restriction we have is that x cannot equal negative 2, which means that x equals 2 is our vertical asymptote. Domain restrictions pretty much always give us vertical asymptotes, for the most part. And then the third piece we need is going to be end behavior. End behavior here is going to look, when x is big, y looks like leading term of the top is x squared, leading term of the bottom is x. That's just x. Now we're back into standard issue polynomial end behavior. X does the, I'm backwards. I can't do this facing the camera. It's disco right. So it looks like X. That's all the information we need. We've got our x-intercepts. They came very easily from this factor thing. -3, +2. We've got our y-intercept. Comes very nicely from the back end. -6, +2 gives us a -3. We got our domain restrictions. That came really nicely from the bottom here. We just set that equal to 0. We got our -2. And we have our end behavior. That comes from the front end. So if you're kind of keeping score, there's 4 things we need, but each of those things only comes from a small piece of the function. This comes from the top. This comes from the back. This comes from the bottom. This comes from the front. So you don't ever actually have to deal with like the whole thing all at once. You can deal with it in pieces. Makes it a little easier. I'm going to erase almost all of this so that I can sketch a graph. Okay, so here's our axes. Let's see what we're dealing with for points and asymptotes and other such things. Our vertical asymptote is going to come in at x equals 2. Sorry, -2. What am I doing? That's not right. This is -2. This has to be -2. It's okay. No one saw that. It's not like this is being recorded or anything. X equals -2 is our vertical asymptote. Disco right is going to be our end behavior. So whatever else this thing does, it's going to be going up that way, down this way. Don't have a horizontal asymptote this time because I have that disco right end behavior, which sometimes happens. You only sometimes get horizontal asymptotes, not all the time. I need points. Points. -3, 0 is one of my points. 2, 0 is my other point. Okay. So we can remember from our lesson on polynomials about the multiplicity of x-intercepts and what that means about them crossing or bouncing. Both of these factors have multiplicity 1, which means that the function crosses at both of these intercepts. Makes sense that it crosses here so that it can go down on this side, and it's probably going up here. On this side, I'll connect this. Oh, I missed a point. -3, 0. There we go. There's my other point, which is perfect because I can come down here and catch that, and then follow that asymptote straight down. I said in an earlier video that asymptotes were one of the most misunderstood concepts in pre-calculus, and I said that because most people, when I ask them what an asymptote means, they say that an asymptote is a line that you cannot cross. And that is partially true. You cannot cross a vertical asymptote. Vertical asymptotes come from domain restrictions, which is why you can't cross them. If x is not allowed to be -2, then you can't have a line that goes through x equals -2. If it went through, that would mean we had a value for x equals -2, and we don't. Can't happen. So vertical asymptotes do have that property. You cannot cross a vertical asymptote. Horizontal asymptotes don't have that property. You can cross horizontal asymptotes as many times as you like. It doesn't matter. Horizontal asymptotes are about end behavior. They only matter when x is really, really big. If x is small, doesn't matter what the function is doing. It can bounce back and forth across a horizontal asymptote any number of times. I want to emphasize this can't cross a vertical asymptote thing because based on the way this is graphed, it kind of looks like this is still angling. So this is going to be sort of a weird exaggeration of what this graph looks like, because it doesn't look like this, but I want to emphasize that as this gets closer to this asymptote, it stops going at an angle. It starts going basically straight down. It looks like this straight line. That's what the asymptote means. Is a line that the function sometimes looks like. So the closer you get to here, the more it looks like a vertical line. There's no slant to it anymore. It's just down. I'm going to cut this video here. We can start right in on another one pretty much immediately. Stay tuned.